Hey, so this is Christy Feller at Yadkin Early College. Math 2, Law of Cosines. So the law of cosines is another way for us to find missing side lengths, missing angle measures, and that sort of thing when we have triangles. Okay, most of the time when you use the law of cosines, you're using this on a triangle that's not a right triangle. And remember, a right triangle has a 90-degree angle. So you'll see there's a triangle on the screen here. That triangle is not a right triangle. Okay, remember how we label? Capital letters go at the angles, lowercase letters go at the side lengths. Okay, so as we're using the formula, which you can see there are 3 versions written on the screen here. As you're using the formulas, remember that the lowercase letters are your side lengths. Now let's talk about this formula. This is the most common way that the law of cosines is written. Sometimes you'll see people who will rewrite the formula so it's written as what looks like a fraction form or that thing. That just means they've rewritten it and moved things around. You know, you can always change the way formulas look. Anytime you have an equation, you can move things around, add it to both sides or whatever, okay? So, but the most common way to write the formula is what you see here on the screen. Now, there are 3 versions on this screen. You're going to see the first version here, it starts with a squared, and then you'll see the rest of the variables that are written in that formula are b and c. You don't run into an a again until you get to the cosine of a, and that's a capital letter, so you're again talking about an angle measure. In the second version of this formula, it's equal to b squared. Okay, and then you'll see the rest of the variables in that formula are a and c until you get to the angle measure again, which matches up with what the formula equals. Okay, same kind of pattern here down here with your third version of the formula. Now the reason they write it in 3 different forms there is it depends on which side you're missing and which sides you're given. So it really does the same thing. If you look at these formulas, you should see that other than there being different letters in places, it's pretty much the same thing. Now the other thing I want us to point out about this formula, let's pick this one. Look at this part right here. C squared equals a squared plus b squared. I'm hoping that you guys are sitting there thinking, oh my gosh, that's the Pythagorean theorem. Yes, it is. Okay, you'll notice the Pythagorean theorem shows up in all 3 versions of this formula. How can that be? Remember, your Pythagorean theorem you only use with right triangles. You can't use that with any other triangle. Well, it still just comes down, and it's what makes the formula work, okay? Most of the time when you're using the law of cosines, and we're going to talk about this later on in the presentation, but most of the time when you're using the law of cosines, you are given 2 side lengths and only 1 angle measure. And when you remember with your Pythagorean theorem, for right triangles, you're given 2 side lengths. Okay, so that's how it kind of relates and coincides there. So let's keep going and see how we use this bad boy. Alright, so we're given a triangle. It is an obtuse triangle. We know that because it does have one obtuse angle here. Change up colors of my pencil. Okay, so we're given side length C, and we're given side length A, and we're given angle measure capital B. Alright, so I'll just go ahead and give it away. The next slide tells us what we're trying to solve for, but we're going to be solving for side length B. Now, since this is an obtuse triangle, and since we're given 2 side lengths and 1 angle measure, we're going to use our law of cosines. Convenient, right? Okay, so the objective. We're finding the measure of side length B. Alright, again, going over what we're given 2 side lengths and we're given an angle measure, which just so happens is exactly what we need in order to find the side length of side B. So, first, choose the correct formula. I'm using the one that already has b squared by itself. It's just It's just the one we use, okay? Since we're trying to solve for b, we'll use this one. So it's a squared plus c squared minus 2ac times the cosine of b. Alright, so your next step is to simply substitute in the information you're given. So since a is 47, we substitute in 47 squared. C is 38, so we substitute in 38 and square it. The 2 is from the original formula. 47 is your A, 38 is your C. Cosine of capital B, since we know that angle B is 134, we substitute that in. Alright, so now the simplifying part can be a little tricky. It has a lot of steps, as you can see on the screen, so you need to make sure you take it step by step. It's very easy when using the law of cosines to make a minor error. Remember what I've told you and told you and told you and told you. 98% of the errors in mathematics are because of a sign. We find them every day. So, as we simplify, 47 squared is 2,209. 38 squared is 1,444. Alright, I'm keeping this minus sign, and you'll notice, hopefully, that I have put in parentheses. Oh, I'll try to change that. Let's try that again. I've put in parentheses here, okay, because of this minus sign from the formula. Because after the minus sign, you have a whole lot of multiplication to do, and you need to make sure that you're doing all this multiplication together. Alright, so do 2 times 47 times 38, alright, and go ahead and simplify that. Take that answer and multiply it by the cosine of 134. You should get negative 2,481.319. Okay? Yes, getting a negative number is okay here. It's mainly because you're taking the cosine of an angle measure that's greater than 90 degrees. If you want to test it out, try finding the cosine of, say, 100 degrees or 105 and see if you don't get a negative answer. Alright, so once you've got that value, you've got a double negative sign here. We're subtracting a negative, so that changes it to addition. I've gone ahead and written that in red, but I want to point it out again. So we do our addition. 3653 plus 2481, you get 6,134.319. Alright, so since that equals b squared, we now have to take the square root of both sides. So you take the square root of b squared, which gives you b. Okay. Then you take the square root of 6,134.319, and you should get 78.32. So the length of side B is 78.32 units. Alright, so again, like I told you earlier, we talk about this again. When do you use the law of cosines? When you are given a triangle, and for now we're practicing with triangles that are not right triangles, that have 2 side lengths and 1 angle measure. You can also use this when you have a right triangle or a non-right triangle that has 3 side lengths and no angles. Alright, so you do it a little bit different, but you're still going to use the same formulas, but you could use this if you just are given side lengths and no angle measures. And then my question to you, and what I'd like for you to look up, can you use the law of cosines on a right triangle? Alright, so test it out, see what you get. See ya.